Okay, good morning, everyone. Today I will talk about my research about the study of shared energy storage considering battery degradation on the remote island. I would like to say many thanks to the International Conference on Green Energy, Computing, and Sustainable Technology, or GCOS 2024, for this program. My name is Lisa Asri. I will present today and my supervisor, Professor Hirosaki, and my co-supervisor, Professor Daisuke Kudara, uh, from University of Tsukuba. Okay, before I talk more, I will introduce the outline. It will be introduction about what kind of the background of my research. The number two, the system design, what kind of the tool I use for my research. And the third is the result and discussion, what kind of the outcome I got from my research. The fourth conclusion, what the final I can tell you. Okay, talk about the electricity. Electricity around the world is only 13% still has a lack access to electricity and how to handle this one. So people using renewable energy such as solar voltaic technology and it's very popular around the world. But the problem is the how to anticipate the uncertainty of the weather. So they use the battery storage to support in the solar PV. But the problem, such a kind of the renewable energy, there will be lack of the economical thing and technology. This is a big problem. As you can see, for the solar PV, they can maintain, just clean it, or such a kind. If they will be such a dirty, they will be just clean it or everything to handle it, easy handle it. Compared to the battery, it will be more complex. So, in the other thing, there is to focus on the study to minimizing the economical cost. The others researcher suggest using shared energy storage. But the problem when the using shared energy storage, it will be increasing the charging and discharging of the battery. It means it will be decreasing age of the battery. So the study will talk about the shared energy storage and the battery degradation. They will be considering each other. The previous research talked about the battery energy storage and the remote microgrid or such a community, the macro microgrid. And then the other thing, the battery degradation only discussed it into the urban area and industrial park. So what is the new in the study? The study proposed using shared energy storage, considering battery degradation and estimate cost of the battery degradation in the remote area. The objective of the study in consideration of the battery degradation, the objective is study to compare between individual, neighbor, and communal scenario inside of the operational costs. So what kind of individual and neighbor and communal scenario I will talk next slide. So before I talk about the scenario, I will talk about the main consideration, the battery degradation, how I limit the battery degradation. So I using limitation of the excessive operational of the battery, such a kind limitation of the state of charge. So limit the state of charge, it means the amount of the energy can be put into the battery and the limitation of the charging, which a kind, but still the objective to like the individual, neighbor, and communal. Such an individual scenario, it means each prosumer has owned the battery. They don't need to share it. And the neighbor scenario, it means one battery can be used for the two prosumer. It means the neighbor prosumer, nearby prosumer can use together. And the communal scenario, it means one battery can be shared for all prosumer in the community. And this time, individual and communal already discussed into another literature review. Such a communal scenario can be used, but the neighbor is a new or novelty in this study on my research. So the system design can be used in here, simulation flow, as you see, input data, demand electricity, solar insolation, and battery capacity. The objective function is minimizing cost and maximizing revenue. The cost is from the grid system. The grid system in the remote area in the study we'll talk is from the diesel generator. So it means we need to minimizing this one. And the battery degradation, such as charging and discharging, we want to minimizing limitation of the excessive charging and the revenue from the demand shifting and the solar PV. The output data will be output operational cost, the battery operation, net demand, and self-consumption rate will be used for the evaluation index. How about the inside the methodology I use? I'm using the mixed integer linear programming, such as you can see in here. I'm using sorry, I'm using objective function and the balance equation to maintain supply and demand and the maximizing of the solar PV and the SOC, like I talked before, like the limitation, charging and discharging can be operate at the same time, and it will be used in the binary operation. For the neighboring scenario and the communal scenario, it means each prosumer has the same amount of electricity. It will be fire, fair, and the communal scenario is same too. It will be justice with the all prosumer who connect together because it will be more complex in the communal. But with the neighbor, we want to use the individual approach, but using the shared energy storage. And then another input data and assumption in here, consumer electricity demand. I use the real data from the National Electricity Plan Indonesia and the solar radiation from the Meteorology, Climatology, and Geophysics Indonesia for the assumption the battery storage. Such as each storage for the individual, it will be more low than lower than the communal scenario. It means like the 1.2 compared to the communal scenario is like 5.6 kilowatt hour. And the power capacity, it will be same for the old scenario. But the cost degradation for each scenario, it will be different. The highest cost, it will be on the individual because they use their own expense. But the communal, such as share energy storage, they divide it. So it means it will be lower than the individual scenario. And here, as you can see, result and discussion of operational cost. After running the simulation, the mixed integer linear, I got that the main objective function neighbor scenario can reduce 4.97%, and the communal scenario about 3.54%. It means compared to the individual scenario, neighbor scenario can reduce more operational cost. The difference is about the 5% between neighbor and communal, but for all the things, shared energy storage can reduce operational costs. But how about the battery operation inside the battery operation? Because we talk about the battery degradation. In here, we see like the individual scenario in the A figure, B in the neighbor scenario, C in communal scenario. Increased capacity of the battery can be changed pattern charging discharge, but increasing charging discharge, it means it will be more battery degradation or the edge of the battery will be lower each per day. And for the individual scenario, it will be less battery degradation. And here, about the net demand, we talk on here. What is the net demand? It means the pattern of the prosumer using their energy from the grid system. So you can see in effect of the shared energy storage in here provide more the demand shifting. It means the more prosumer change their demand shifting in here, an individual scenario can increase only the consumption of the 9 pin. It means they only change by their own pattern, but the shared energy storage, such as neighbor and communal, can change because they interact with the other prosumer. And then from all result, I want to evaluate what kind of the penetration of the renewable energy can be used in here. The one unique finding here using the self-consumption rate, neighbor scenario maybe provide more reduction cost, but provide less SCR. It means SCR, more penetration of renewable energy in here, and individual scenario provide more SCR. It means even we can reduce the operational cost, but the more penetration of renewable can be used in here individual scenario. So it means if you want to increase the SCR, or if you want to minimizing operational cost, or if you want to minimizing the battery degradation. And then my simulation result, neighbor scenario can reduce about the 4.97% and communal about 3.54% compared to individual scenario, but individual scenario provide less battery degradation and provide high self-consumption rate. In the future, I will discuss about the peer-to-peer communication and share energy storage will be considered into remote microgrid. Thank you for attention. Arigato gozaimashita. Terima kasih.